So section 2.4 is titled Dimensional Analysis. Essentially what we're going to do in section 2.4 is we're going to be given a measurement in one unit of measure, and we'll be asked to change it to another. Like we'll be asked to change 2 miles into feet, or we'll be asked to change 14 pounds into kilograms. We're going to change from one unit of measurement to another unit of measurement, and this is called dimensional analysis. In this section, we have to know a few equivalencies to change from one unit of measure to another unit of measure, and I don't have any of these memorized. I don't expect you to have any of these memorized. When we get to the test over this section, you're going to be given all of these equivalences. I actually have 2 pages of equivalencies. One are equivalents within the metric system, and then some other equivalences that we'll get to as we need to. So let me just kind of jump in to start doing an example to show you how we're going to do this. So in this section, we're going to be asked to change from one unit of measure to another. And in the first example here, I want to change from 2,000 centimeters to kilometers. One way to work in the metric system is to move the decimal to change from one unit of measure to another. Let me not do that quite yet. Let me show you how we're going to do most of the problems in this section. In this section, we're going to convert from one unit of measurement to another unit of measurement, mostly by multiplying by a fraction that's equal to 1. In the numerator of that fraction, we're going to write the units that I want to end up with. In this problem, I'm asked to change 2,000 centimeters into something that's kilometers. So in the numerator of the fraction that I'm going to multiply to change from centimeters to kilometers, I'm going to put the units I want to end up with, which is kilometers. In the denominator, I'm going to put the units that I'm trying to get rid of, in this case, centimeters. To change from 2,000 centimeters to kilometers, I need to know a relationship between centimeters and kilometers, and it's going to be on this sheet. On this sheet here, everything in this table, at least in this top row or this top table, are equal to each other. This top row, or this part of the table that I've highlighted, tells me that 100 centimeters is the same as 0.001 kilometers. So on the fraction that I'm starting to create, I'm going to put in the numerator 0.001 kilometers, and in the denominator, I'm going to put 100 centimeters. This is actually equal to 1 because 0.001 kilometers is equal to 100 centimeters. So I'm multiplying by a fraction that's equivalent to 1. So what it's going to do is it's going to change how the fraction appears, but it's not going to change what the fraction ultimately equals, because multiplying by 1 doesn't change the value. Multiplying by 1, you get the same, you get an equivalent unit, except in a new dimension. I don't know that that was said so smoothly, but I'm going to live with that for now. To do this, numbers in the numerator I have to multiply by, numbers in the denominator I need to divide by. I'm simply going to go 2,000 times 0.001 divided by 100, and this is going to give me 0.02 for the number. In my units, I canceled out the centimeters. I'm left with kilometers. That's the way that I'm going to do these problems in this section. An alternatively correct way, and a possibly easier way, is the way I was taught in grade school, and that's by moving the decimal. So if I wanted to convert from 2,000 kilometers, 2,000 centimeters, into kilometers, I have to understand that there's an implied decimal after the 0 in 2,000, and I need to figure out on my chart how far it is between centimeters and kilometers. And between centimeters and kilometers, it's 1, 2, 3, 4, 5 spaces. I can convert between centimeters and kilometers by moving the decimal from the centimeter number 5 places and in the opposite direction. On this chart, kilometers are to the right of centimeters. If I want to convert from centimeters to kilometers, I need to take the decimal and the centimeter number and move it 5 places to the left. So if this decimal right here that's implied but not normally written, if I take it and move it 1, 2, 3, 4, 5 places to the left, I get something that's going to be equal to 2,000 centimeters, that's in kilometers. If I move the decimals past numbers, I have to put a 0 in any place I move the decimal where there wasn't a number. So this would say 2,000 centimeters equals 0.02000 kilometers. If you look at the answer my calculator gave me, it was 0.02 kilometers. This is because the zeros in the last positions there aren't necessary. So I could say that 2,000 centimeters is equal to 0.02 kilometers, and I don't have to do it with units. Of course, anytime you're writing a number that's a decimal that doesn't have a number to the left of the 0, or left of the decimal, you could certainly put a 0 there. And I could have, for my answer to convert 2,000 centimeters to kilometers, written either 0.02 kilometers or 0.02 kilometers. Those both would be correct. Let's do another conversion, and I'm going to do my conversions using fractions. So I want to change 15L, that 15L is liters, and I want to change to cups. So let me look at my sheet and see if I have any relationship between liters and cups, because if I do, that's what I'm going to use. And on this sheet under the volume column, I see that 1 cup is equal to 0.24 liters. I'm going to use this fact to convert from cups to liters, and I always convert using fractions. So I'm going to start off with the 15 liters. I'm going to multiply by a fraction, and I need to get the units in. In the numerator, I put the units I want to end up with, and I want to end up with cups. In the denominator, I want to put the units I want to get rid of. I want to get rid of liters. Now I'm going to put 1 cup in the numerator, so 1 next to the cup, and 0.24 next to the liters in the denominator. When I do this, the liters are going to cancel. I'm going to wind up with cups, and I need to get a number. The number I could get by doing 15 times 1 divided by 0.24. I multiply the number in the numerator, I divide the number in the denominator. Because the number in the numerator is a 1, I really just need to do 15 divided by 0.24, because the times 1 isn't going to change it. So whether I do 15 times 1 divided by 0.24, or if I do 15 divided by 0.24, I'm going to get the same number, and that's the number that's going to go in my answer. And the units that are going to go in my answer are the units in the numerator. So I'm going to say 15 liters is equal to 62.5 cups. If you're taking chemistry, or if you've ever taken chemistry, you do a bunch of this in chemistry, and this will be an easy section for you. If you haven't had it in chemistry, then it might be a little bit harder, and it'll take a little getting used to. And the hardness is going to come on a problem just like I'm staring at right here. I want to convert from 90 kilograms to ounces. So this is weight. So I'm going to look in my weight and see if I find something that relates kilograms and ounces. And unfortunately, the only thing that I see that has kilograms has pounds, which is good, but I don't see one fact that relates kilograms to ounces, but I see a fact that relates kilograms to pounds, and a fact that changes pounds to ounces. What I'm going to do is I'm going to multiply by 2 different fractions to get the job done. My first fraction is going to convert kilograms. It will have kilograms in the denominator to get rid of the kilograms, pounds in the numerator to turn me into pounds. Unfortunately, that's not going to be good enough, and I'm going to have to use the second fraction to get out of the pounds that I'm going to convert to into the ounces. And let me show you how to do that real quickly. So sometimes we'll have to do 2 fractions, sometimes maybe even 3, to get where we need to get. So immediately, when I was asked to convert from kilograms to ounces, best case scenario was to look in this list and see something that had kilograms and ounces and only kilograms and ounces, but I don't see this. I need to see something that has kilograms, and in this list the only thing that has kilograms is 1 pound is 0.45 kilograms, so I'm kind of stuck using that. The only way to get out of the weight of kilograms is using this fraction, because it's the only fraction that has kilograms in it. To get rid of kilograms, I'm going to put kilograms in the denominator, and I'm going to put pounds in the numerator. That fraction, what it's going to do, it's going to cancel out the kilograms, and it's going to convert this to pounds. If I just did this one step, I will have converted 90 kilograms into pounds, but that's not what I want to do. I want to convert to ounces. So I'm also going to multiply by this fraction, and in this fraction, now my units that aren't marked away as pounds, I want to get rid of the pounds, and what I want to get rid of goes in the denominator. What I want to end up with, the units I want to end up with, goes in the numerator. So first I want to get rid of kilograms, so I put the kilograms in the denominator. I did that by using the only weight that had kilograms. That put me into pounds. Now I want to get rid of the pounds, so I put the pounds in the denominator and the ounces in the numerator, and I'm going to put a 1 next to the pound and a 16 next to the ounces. Now I just need to get the numbers. And to get the numbers, any number that's in the numerator, I'm going to multiply. Any number that's in the denominator, I'm going to divide. So I'm going to put 90, I'm going to multiply by 16, and I'm going to divide by 0.45. So on my calculator, to get the number that I need, I'm going to go 90 times 16 divided by 0.45. Numbers in the numerator get multiplied, numbers in the denominator get divided, and I really don't need to worry about the ones. So for this problem, I should just go 90 times 16 divided by 0.45. I already know the units are going to be ounces because the kilograms and the pounds got canceled. What didn't get canceled is the ounces I wanted to end up with, and my answer to this is going to be 3,200 ounces. Sometimes there's going to be more than one path that will take you to the from the unit that you're given to the unit that you want to end up with. And sometimes if you take a slightly different path, you'll get a slightly different answer. Every one of these equivalencies is really a rounded approximation. When I wrote that 1 inch is 2.54 centimeters, that's maybe not exactly, I don't know what it exactly is, but maybe it's 1 inch is 2.53976 centimeters. So these are all rounded. If you take slightly different paths to get to the answer, you might get a slightly different answer. It's going to be equivalently correct. So sometimes there's going to be more than one path that we can take. And I'll try to point that out if it seems obvious to me. So since we haven't done that much within the metric system, let me work with your problem 1. And in problem 1, I want to convert from 10 meters into centimeters. So I'm going to multiply, if I can find a fraction, and this is staying within the metric system, so I probably can find a fraction that has meters equal to centimeters. Because I want to end up with centimeters, I'm going to put the centimeters in the numerator. Because I want to get rid of meters, I'm going to put the meters in the denominator when I go to do number 1. The relationship that I'm going to need, I need a relationship between meters and centimeters, and on my sheet, everything in this row they're all equal to each other. So this is saying that 100 centimeters, I'm sure I'm going to meters, is equal to 1 meter. So the unit that I'm going to use that's going to be implied for this problem is that 100 centimeters is equal to 1 meter. Every one of these relations, every one of these numbers, this should say 1,000 millimeters, all these are equal to each other. So I'm going to put in my fraction 100 next to the centimeters and 1 next to the meter. So 100 next to the centimeters, 1 next to the meter. The meters are going to cancel, and I'm simply just going to multiply 10 times 100 and get 1,000. The answer to problem 1 should be 1,000 centimeters. Hopefully I have the answers around so I can flash up to make sure I haven't messed up. Number 1, the answer is 1,000 centimeters. All right, so problem 3 and 4 within the metric system, so let me flash up to you what you might need here in a second. When I go to do problem 4, I'm changing from kiloliters to liters, so I need to multiply by a fraction. The numerator has what I want to end up with, which is liters. The denominator, which is what I want to get rid of, is kiloliters. For you, you're going from milligrams to grams. To go from milligrams to grams for your problem 3, you're going to need that 1,000 milligrams is equal to 1 gram. For my problem, I'm going from liters to kiloliters, and I'm going to use that 1 liter equals 0.001 kiloliters, because in this table, 1 liter and 0.001 kiloliters are equal to each other. So for my fraction, I knew I wanted to have liters in the numerator because I wanted to end up with liters. I wanted to have kiloliters in the denominator because I wanted to get rid of kiloliters. I took the number from my table, and now I'm going to cancel, and because the 0.001 is in the denominator, I'm going to divide. I'm going to go 20 divided by 0.001 and get 20,000 liters for my answer. When you get done with number 3, the answer you should be getting is 0.045 grams. When you go to do problem 5, you're changing from kiloliters to liters, so you're going to use the same unit that I'm using. When I go to do number 6, I'm changing from kilograms to grams, and so I have to have a relationship. I'm going to start off doing number 6 by making a fraction. In the numerator, it has the units I want to end up with. I want to end up with grams. In the denominator is the units I want to get rid of. I want to get rid of kilograms. And I'm going to use the fact that 1 gram is 0.001 kilograms. So I'm going to use 1 gram is 0.001 kilogram, because every one of these numbers are all equal to each other. So 1 gram is 0.001 kilograms. When I go to do my number 6, the number that isn't a 1 is in the denominator, so I'm going to divide. And the number, if I actually could have entered it right, that I should get is 8,000. So 8 kilograms is 8,000 grams. When you go to do number 5, the answer that you should be getting is 5,000 liters. All right, so still within the metric system, let's do number 7. I won't do number 8. So for number 7, I'm going from kiloliters to centiliters. And to do kiloliters to centiliters, I'm going to use the kiloliters and the centiliters. I'm going to use that 0.001 kiloliters equals 100 centiliters when I go to do your problem. And when I go to do number 7, I start off with kiloliters. The fraction that I'm going to multiply by is going to have centiliters in the numerator and kiloliters in the denominator, because what I want to get rid of goes in the denominator, what I want to end up with goes in the numerator. The numbers that I'm going to put next to the centiliters is 100. The numbers I'm going to put next to the kiloliters is 0.001. I'm going to multiply by the 100 and divide by the 0.01. So I'm going to go 0.25 for that, and then times 100, and then divided by 0.001. And the number that I'm going to get is 25,000. And the units I'm going to get are the centiliters, because the kiloliters are going to cancel. I'm going to double check that I haven't messed up on number 7, and I see 25,000 centiliters, so I know I did perfect. All right, now we're going between measurements. So for you to go from 5 feet to inches, you're going to have to look for a relationship between feet and inches. And, well, there's a beautiful one. For your number 9, I suspect you're going to want to use that. I'm going from feet to centimeters, so for my number 10, I'm going to use this. So if I was doing number 10, I'm going to start off with 6 feet. I'm going to multiply by a fraction. I want to end up with centimeters, so centimeters goes in the numerator. I want to get rid of feet. Feet goes in the denominator, and I'm going to use that 30 centimeters as equal to 1 foot. The feet are going to cancel. I'm going to multiply the 60 and the 30 and get 180. And my 6 feet is going to be 180 centimeters. When you do your problem 9, you should get 60 inches for your answer. So many sheets of paper here, it's kind of a nuisance. All right, let's look through number 11 real quick to go from miles to feet. I think there's a perfect relation for that. So when you're doing number 11, you're probably going to use that 1 mile is 5,280 feet to do yours. And I need to go from yards to meter. I'm going to use that 1 yard is 0.9 meters. So for my problem 12, I'm going to start off with 4 yards. I'm going to multiply by a fraction. I want to end up with meters. I want to get rid of yards. I'm going to put a 1 next to the yard and a 0.9 next to the meter. The yards are going to cancel. I'm going to multiply the 4 times the 0.9 and get 3.6. My answer is going to be 3.6 meters. You're going to do something similar with the 5,280 feet is equal to 1 mile when you do your problem 11. And the answer that you should come up with for problem 11 is 15,840 feet. For your 13, we need to do volume. We need to go liters into cups when we're ready to use that. So for your number 13, you're probably going to use that fact that 1 cup is equal to 0.24 liters because that's what I'm trying to change from. I'm trying to change from liters to cups. Best case scenario is to find one equivalence that has both of those, and I can do it with one fraction. I need to go from 40 ounces to cups, and I'm going to use that 1 cup is equal to 8 ounces. It's actually 8 fluid ounces, but I can live with ounces. So I'm going to go 40 ounces. My fraction is going to have cups in the numerator because I want to end up with cups, ounces in the denominator because I want to get rid of ounces. I'm going to put a 1 next to the cups and 8 next to the ounces. The units ounces is going to cancel, and then I'm going to go 400 divided by 8 and get 50. So for problem 14, I should get 50 cups. When you do your problem 13, I wrote 16 and 2/3 cups. If you wrote for 13, because it didn't say round to 2 decimals, but if you wrote 16.67 cups, I can completely live with that. And equivalently, if you wrote 53rd cups, I can live with that. Those are all equal to each other. I didn't remember in the instructions that it said round to 2 decimals, so but I'll live with 2 decimals worth of rounding if that's what you choose to give me. In chemistry, the rounding is an incredibly big deal, but not so much here. All right, we both get to go from fluid ounces to liters, and to go from fluid ounces to liters, this is too bad. So to go from fluid ounces to liters, the only thing that I see with ounces, I see fluid ounces to milliliters and ounces to cups. That's no good. I'm going to use getting ounces to milliliters. So when I go to do my problem 16, I'm going to start off with my 8 fluid ounces. And ultimately, I want to get to liters. The best I can do is get fluid ounces in the milliliters because that's the only relationship that I see that's useful. This is also fluid ounces, but cups is by no means useful. So I'm going to change from fluid ounces to milliliters by putting milliliters in the numerator and fluid ounces in the denominator. And then I'm going to put 30 next to the milliliters, 1 next to the fluid ounces. This will get rid of the but it won't get me into liters. So the next thing I'm going to do is, now that I'm into milliliters, I'm going to get rid of the milliliters and get myself into liters by using my metric system. So I need to convert from milliliters to liters, and this table right here says that 1,000 milliliters, that's the number under the milliliters, is equal to 1 liter. So on my next fraction, I want to go from milliliters to liters. I'm going to put 1,000 next to the milliliters and 1 next to the liter because of this equivalence I got from the bottom table. And I multiply numbers in the numerator, I divide numbers in the denominator, so I'm going to go 8 times 30 divided by 1,000, and I get 0.24 liters for my answer. I certainly could have written 0.24 liters. My calculator just didn't give me the 0 in front of that number, but that's completely fine if I write it or if I don't. For your problem 15, you're trying to get 0.09 liters. And again, you can just write 0.09. If you don't write the 0 before the decimal, that's okay. Our 17 and 18 are backwards. I'm going from kilograms to ounces. You're going from ounces to kilograms. But let's see if we can do this. In the weights, unfortunately, for me, I need to start with something that has kilograms. The only one that has kilograms is that one. For you, you need to start with ounces. There's 2 of them that have ounces, and it turns out that this one with ounces is probably better to use. Let me go through your problem instead of my problem. So if I was doing problem 17, I need to pick something that has ounces. Well, I guess they both will work. I could pick this one that goes from ounces to pounds, and then use that one that goes from pounds to kilograms, or I can go from ounces to grams and grams to kilograms. This is one of the times that I kind of mentioned where if you do, there's multiple ways to get to the answer, and if you choose different ways, you'll get slightly different answers. Let me try to illustrate that. Let me use these two doing your problem 17. So for number 17, one way to do this is to first get rid of the ounces and get the ounces into pounds by using 1 pound is 16 ounces. When I do that for problem 17, that's going to get me in a good position. It gets me into pounds, but I want to get into kilograms and not into pounds, so I need to multiply by another fraction because now I'm in pounds, not in kilograms. That fraction is going to have pounds in the denominator, kilograms in the numerator, and that I'm going to use 0.045 or 0.45 kilograms is equal to 1 pound. This is one way to get to a correct answer, and let me do this real quickly. Numbers in the numerator get multiplied. I do the multiplication first, so 400 times 0.45. Numbers in the denominator get divided by 16. Doing it this way, I get 11.25 kilograms. My units are kilograms because I crossed out the ounces, I crossed out the pounds. I'm left with the kilograms. Unfortunately, there's another path that's equally obvious. And if I took this other path, I'll probably get an answer that is slightly different, but equally correct. So if you decided to use 1 ounce is equal to 28 grams, because you saw that and you said, heck, I can go from ounces into grams by using 28 grams is equal to 1 ounce. This would be a fair way to do this. If you do it this way, now the ounces are going to cancel. I'm in grams. Unfortunately, I want to be in kilograms. And to be in kilograms, if I'm now in grams, I need a fraction that has grams in the denominator, kilograms in the numerator, and the fraction that I'm going to use for that has grams and kilograms, I got from this table that 1 gram is 0.001 kilograms. So I can say 0.001 kilograms is equal to 1 gram. And now, when I go to get my number, all the numbers in the numerator, so it's straight multiplication, I would go 400 times 28 times 0.001. And look at this, I get 11.2 kilograms. So I get a slightly different answer. I have to call them both correct. And the reason it's a slightly different answer is because most of these are rounded. This 0.45 grams maybe is really 0.449 grams. And I just rounded everything down. And so taking different paths can lead to slightly different answers. And the answer that I wrote down when I did problem 17 was 11.2 kilograms and not the 11.25 kilograms that I got by using a different path. So the path that you could take can make a slightly different answer. So if you get an answer that's slightly but really close to mine, then you probably just took an alternate path that's equally correct. Now we're going for you to go from ounces to tons. This is definitely weight. And unfortunately, when I look from ounces to tons, I have ounces to grams and ounces to pounds. You have to pick one of those because they're the only two weights that have ounces. You should probably pick ounces to pounds, and then you'll be able to pick pounds to tons. So when you go to do your problem 19, the units that you're probably going to use are the ones that I just checked. Me, I'm going from yards to kilometers. It would be nice if in my length I had something that went from yards to kilometers, but I don't. But I'm going to take I see two different yards. I'm going to take the yards to meters when I go to do my problem. So for problem number 20, I'm going to start off with my 300 yards, and the only fraction I see with yards that seems useful is that relation between yards and meters. I'll put meters in the numerator, yards in the denominator because I want to get rid of the yards. I'm going to put 1 next to the yard and a 0.9 next to the meter. Now in my problem 20, I'm in the world of yards, out of the world of yards into the world of meters. I want to get out of meters and into kilometers. I get out of meters and into kilometers by finding a relationship between meters and kilometers, and the relationship that I'm going to use is 1 meter is 0.001 kilometers. So 1 meter is 0.001 kilometers, and now I'm just going to do the math for number 20. I'll go 300 times 0.9 times 0.001, and for number 20 I'm going to get 0.27 or 0.27 kilometers. When you go through and finally get an answer to your problem 19, the answer that you're shooting for is 0.3125. I did a T for tons, but you certainly could write the word tons down. I'm getting a long ways into this video, and there's so many more problems. We're only halfway through the problems. Next thing we're doing is liters to fluid ounces. So that's going to be volume. Let's see what I have with liters. I have liters to quarts, liters to pints, liters to gallons. No liters to fluid ounces, unfortunately. This is a really unfortunate one. So I'm trying to go from liters to fluid ounces. So, I guess I can go from liters to cups and cups to ounces, assuming that these ounces, because it's under volume, are actually fluid ounces. So when I go to do my problem 6, I'm going to use cups from liters to cups, and then cups to fluid ounces. So first, I'm going to start off with my 6 liters. I'm going to multiply by something to get me out of the metric into the English system by putting the liters in the numerator and the cups in the denominator. Putting the cups in the numerator and the liters in the denominator, because that will get rid of the liters, end up in cups. The numbers I'm going to put next to the cup is 1 cup. The number I'm going to put next to the liter is 0.24 liters. That unfortunately only takes me to cups and not into fluid ounces. Now I'm going to use this one, and I'm going to put cups in the denominator because I'm trying to get rid of cups, and I'm going to put ounces, which is really fluid ounces, in the numerator. And I'm going to use the fact that 1 cup is 8 fluid ounces. The cups are going to cancel. I'm going to multiply the 6 and the 8 and divide by the 0.24. So I'm going to go 6 times 8 divided by 0.24, and I'm going to get 200 for the fluid ounces. When you get your problem 21 done, correctly done, the answer you're going to come up with is 700 fluid ounces. All right, our 23 and 24 are backwards. We want to go from kilograms to ounces, and I think we've done that already. And this is the one where there's 2 ways to go. And for me to go from kilograms to ounces, let me just use these two this time. I could use those two, and they both will work just fine. And if you use a different path, you'll get a slightly different answer, but it'll be close. And I don't know which way I did when I did number 23 on my key. Let's just do 23 then. So to go from 10 kilograms into ounces, I'm going to have to do it with two fractions. The first fraction needs to be able to get rid of kilograms, so it needs kilograms in the denominator. And I just have this choice. This is really the only choice I see. It's the only one that has kilograms. So maybe we don't have so much in the way of choices for your problem like we did for my problem. Because I'm trying to get rid of kilograms. The only one I see with kilograms has 1 pound equals to 0.45 kilograms. That takes me out of the world of kilograms into the world of pounds. But in 23, I want to end up with ounces. So to end up with ounces, I need to get rid of pounds and wind up with ounces. To get rid of pounds, pounds goes in the denominator. To wind up with ounces, ounces go in the numerator. I'm using this fact that 16 ounces is equal to 1 pound. Pounds are going to cancel. And now I'm going to do the multiplication first and the division last. I'm going to go 10 times 16 divided by 0.45. And I'm going to round to 2 decimals, but I certainly could have hit math, enter, and did a fraction. So for 23, I can live with 3,200 over 9 ounces if you just change the decimal into a fraction by hitting math and then enter twice. Or I'm always going to live with rounding with 2 decimals, and this rounded to 2 decimals is 355.56 ounces. If we look at my work, look at this. My work has 357.14 ounces. And let me try to make sure I haven't made a mistake. So I started at 10 kilograms. I used 1 pound as 0.45 kilograms. I did 1 pound as 16 ounces. I feel good about that. I do 10 times 16 divided by 0.45, and I get that exact number. The way that I did this was sneaky. The alternate way to do this is to first go from 10 kilograms to grams. To go from 10 kilograms to grams, I'm going to put grams in the numerator, kilograms in the denominator, and the fact that I'm going to use here is that 1 gram is 0.001 kilograms. So I'm going to say 1 gram is 0.001 kilograms. That's going to cancel out the kilograms, put me into grams, and then I could multiply by the fraction that has grams in the denominator, ounces in the numerator. The grams will cancel. I'm going to use that 1 ounce is 28 grams. I'll get the same units, meaning ounces, but probably a different number. To do this one on my calculator, because these are both in the denominator, it's a double divide. It's going to be 10 divided by 0.001 divided by 28. And when I do that, look, I get 357.14 ounces. This is the answer that I wrote for 23 when I wrote my key. So it's very possible for some of these problems for you to be doing perfectly correct work, taking a different path, because each one of these, especially these metric ones, are roundings. The metric between English are roundings. You can get a slightly different answer, but close. 355 is kind of close to 357, so I'm going to have to live with that. All right, 25 and 26. Let's see if we can find the path for 25 to go from tons to ounces. So this is weight. The only thing I see with tons is I can go from tons to pounds or tons to metric tons. I think probably for your problem 25, first going from tons to pounds and then going from pounds to ounces is probably going to be the set of fractions that you're going to choose. You're probably going to take 2 fractions. For 26, I'm going to go from kilometers to yards, and I'm going to do that by going, the only thing I see with kilometers is kilometers to miles, so I'm going to go from kilometers to miles, and then miles to feet, and then feet to yards. It's going to take me 3 fractions to get there. I know in chemistry, if you take it, you get a load of fractions. So in my 26, the fractions I'm going to start off with is that 1.6 kilometers is 1 mile. That's going to take me out of kilometers into miles, and then the only thing other one I see with miles is miles to feet. I'm going to do 5,280 feet is 1 mile. That's going to take me out of miles into feet, and now I can use that 3 feet as 1 yard. I want to get rid of feet and wind up in yards. I get 1 yard is equal to 3 feet. Those 3 fractions consecutively, first fraction will get rid of kilometers, second fraction will get rid of the miles, third fraction will get rid of the feet. When I go to do this on my calculator, I would go 2 times 5280 divided by 1.6 divided by 3, and I'm going to get 2,200 yards for problem 26. If you use the 2 fractions to do problem 25, you should have gotten 96,000 ounces. Real quickly, I won't do it all the way out, but when you did 25, you should have started with the 3 tons. The first fraction that you're going to multiply by is going to have you go from 2,000 pounds is equal to 1 ton. And then to go into ounces, I'm going to use 16 ounces as 1 pound. And if you multiply those numbers together, I hope like heck on problem 25, you get 96,000 for the number for your ounces. All right, cups and quarts. Hopefully there's a nice one that relates cups and quarts. I see cups to ounces, cups to liters. The only thing I see is cups to ounces. Oh, I see cups to pints and pints to quarts. I'm going to use these. I'm going to use cups to pints and pints to quarts to get me myself there. For my problem, I'm going to go from quarts to cups, and I'm going to need to do it in 2 steps. First thing I'm going to do is I'm going to get rid of the quarts and temporarily hold myself in pints. Then I'm going to get rid of the pints and end up with cups. You're going to use the same fractions, maybe in a slightly different order because we're going backwards. So for my pints to cups, pints to quarts, I'm going to say that 2 pints is 1 quart. And for my pints to cups, I'm going to say 2 cups is 1 pint. And my quarts are going to cancel, my pints are going to cancel, and I'm just going to multiply the numbers. 8 times 2 is 16 times 2 is 32. I'm going to get 32 cups. When you go to do problem 27, your fractions might be upside down. Your first fraction's probably going to have cups in the denominator, pints in the numerator. Your second fraction's going to have this one flipped over. And when you get done with problem 27, I'm expecting 2.5 quarts. All right, teaspoons and liters. So that's got to be in some sort of volume. And let's see where I see teaspoons. I see teaspoons in milliliters. That's the only teaspoons I need. So I'm going to need to use this, and you're going to need to use this. And we're going to need something that has milliliters in it, which is going to be on my other big table. When I go to do problem, let's just do 29. When I go to do 29, I start off with 100 teaspoons. I want to end up with liters. The only relationship I see with teaspoons is this one, so I've got to use it. And how am I going to use it? I'm going to put teaspoons in the denominator because I'm getting rid of them, milliliters in the numerator because I'm ending up with them, and it's 5 teaspoons, 5 milliliters is 1 teaspoon. I get rid of the teaspoons, which is nice, but I end up with milliliters. I want to end up with liters. Easy enough to end up with liters. I'm going to put a fraction that has liters in the numerator and milliliters in the denominator. That will cancel out the milliliters, end me up in the liters. And I need a relationship between liters and milliliters. That's here. The relationship I need between milliliters and liters is that 1,000 milliliters is equal to 1 liter. That's the unit that I'm going to use for a second here. That 1 liter is 1,000 milliliters. I've got my units all crossed out. I just need to pick up my number. I'm going to do 100 times 5 divided by 1,000. And I'm going to get 0.5 liters, or 0.5. You don't need to have the 0 before the decimal, but you certainly can. So my answer for problem 29, interestingly, On my key, I have 1.5 liters. Let me just make sure I haven't messed up. I think this is just the wrong answer. So I think for 29, it's going to be 0.5 liters, but make sure I haven't messed up yet. I started off with 100 teaspoons. I did 5 milliliters as 1 teaspoon. Seems good. And I did 1 liter as 1,000 milliliters. Let me double check that. 100 times 5 divided by 1,000. This should be 0.5. That's just an error on my key that I'll fix, I guess. All right. Oh, another example. Let me make a part 2 to this video for the rest of this because we're already 45 minutes into this.